What's up, everyone? My name's Jacob Marinelli. I'm a fourth year mechanical engineering technology major here at RIT. Today, I'm going to be walking you through how to use RobotStudio to set up a pick and place array for placing objects into a pallet.
To lay out your robot, I find it most helpful to set everything up before you begin your code. To do this, you'll want to use the import geometry function. I recommend using a .sat file for defining your geometry because this allows you to use snaps. When using something like an STL, the true geometry of the part may not import correctly, and it doesn't let you use snaps for that reason. To position your part, just use the position tool and then set a position. You want to pick a spot within the reach of the robot, but adequately far where it won't have to be bent into a crazy position. So let's try 350, 175, 0 for the Z. We can see our part is rotated there, so we're going to want to adjust it by a 90-degree angle, and that looks about right. So we'll want to apply those changes and then do it again to get our second pallet. Once again, we'll want to say 350. I'll go negative 175 this time, and then adjust it by 90. So now we have two nice work pieces. The next thing to do is we have two nice pallets. We'll want to add our work piece now. This is where the snap function can come in handy. So now that you have your part, you'll want to, or your workpiece, you'll once again want to say set position. But we can zoom in here. We can go into the first field on this, and then you want to use your snap feature, snap center in this case. And then we'll just need to rotate this 90 degrees again. Click apply, and your part's placed. I find it convenient to modify the part to set a color that's distinct from your two palettes to make it easier to see. Next, we'll want to add our end effector to the robot. We're going to use a custom end effector. To do this, I find it useful to jog the robot into a position where all joints are at 0 degrees. To do this, you can use the flex pendant. You'll want to make sure you're in the manual operating mode. Then you can go into the jog window. We can see joint 5 is at 30 degrees. We'll want to click the number key to switch what axes we're moving. And we can see 5 is going to be the up and down arrows. We'll enable our robot so the motors turn on. We'll click hold to run. And now we can just jog it upwards until it's at 0 degrees. All right, we're at 0 degrees. So now, once again, we'll want to use the import geometry function. Browse for your end effector geometry. In my case, I have an end effector mount that we'll want to snap to the faceplate. So once again, we'll use position, set position, and then we'll find the center of our faceplate. We can clearly see that it's not in the correct orientation. So once again, we'll just want to rotate that by 90 degrees. Actually, let's see here. We'll rotate it by 90 degrees, and then we will rotate it again in the y-axis by another 90 degrees. And then 90 degrees again in the z-axis. We'll click apply, and our end effector mount is placed. We'll then want to place the two grippers. Once again, import your part, select position, set position, and then we can use the snap feature again. For this, since it's a rectangular object, you'll want to use the snap object function, and then simply click where you need your part to be. We'll need to use the set position tool again. And then we can click here and we can see it moves our end effector into about the correct position. Once again, we'll need to adjust the orientation. So we'll try here. So we can see that's correct, but we'll need to adjust our Z forward in order to get it to mount flush at the end of the end effector. All right, now we're at 425, negative 22.89, 640 degrees in height. This looks about right, so I'll click apply, and we'll import our geometry again for the next side. Again, we'll use the place object feature, and we'll adjust our angles again. We'll want to rotate this by 180 degrees. And then we'll want to, again, bring this out. I believe the last side was, the two sides will change for their dimensions, but they should be approximately the same. And now we'll want to adjust our Y value again to make sure we get aligned onto the plate itself. All right, that looks like it's about in the correct position, so we'll click apply there. I just made a few fine adjustments there to make our gripper mount to the end effector itself a little better. Now we're going to want to set that as a mechanism. So we'll use the create mechanism tool. First, we'll want to select our base link. Our base link in this case is going to be our end effector mount. We'll use this arrow key to add it as a component. Then we'll click apply. Next, we'll want to add our two moving links. Click this arrow again and then click apply. Need to select gripper 2 there. I've already selected that one. Click apply again, and then we'll hit cancel. Our links are now there. We forgot to specify this one as the base link, so we're just going to go back in here and say this base link. You'll now see a green check mark here that says we can move on to the next stage. This is going to be the joint stage. All of our joints are going to be prismatic as they move in a linear manner. We're going to want to set our positions. In this case, this link is going to move forward by 10 millimeters. Our joint limits will be 0 and 10 millimeters. We can test that it's moving correctly by this. And we can see there that it's closing pretty nicely. Maybe our range isn't quite defined well enough, so we'll add another 2.5 millimeters to let it close a little farther. That looks good. So now we'll click apply, and we'll do the same thing for the next one. But instead, we'll reverse our direction of travel. Again, prismatic, 12.5 is our limit. And then for the joint limits, even though it's moving to a position in negative, the joint limit should always be positive. So just type 12.5 there, check that it's working right, and then click apply. One of the most important things is setting up your frame properly. To this, we'll want to set it as the base link, and we'll want to position it. I believe from our previous work, we were about 200 or 410 millimeters in the X direction and about 600 millimeters up. Once you can see that it's around the center of where you want to be, hold on there, I have a touch screen, so I want to say 410, 0, and then about 625. And I'll want to click out of typing in that box. We can use your screen to pan there And that looks just about good, except we'll want our Z direction facing in the vertical orientation in the manner that we use the robot. So we'll want to rotate it by 90 degrees to achieve this. You can see we're not quite centered there. So we're going to just add a little bit of Z height until we're centered. And that looks good. We can move this back just a slight bit so it's more in the center of your end effector itself. But depending on what you're doing, that may not matter all that much. Let's click OK now, and then we'll set the calibration. The calibration, I just use the same value as I did it before. So that's going to be 4050 and then 625. We'll just hit enter there, and we can compile the mechanism. We'll want to add our poses now. We'll just click add. Then we'll name your pose. So this pose will be open, and this will be our home pose. Then we'll want to add a second position, closed. And this is the position where your joint will be closed. So once again, you'll want to hit apply and OK. Now we can see our joint closed. From here, you'll want to start defining your work pieces or your work objects and your targets. This is really easy to do on RobotStudio. We'll want to zoom in here. You'll want to go into Home or Paths and Targets. You'll want to select your controller, and then you'll see an option for tool data as well as work objects and targets. We'll want to create our tool data first. For this, we can just use what we did previously. We'll just want to define a tool frame using a position. I prefer just clicking right on it in the center there. So we can accept that. And we don't need to rotate it. Make sure you have a mass value and then set your data type, and you can create it. I like to name mine something unique. So I'll put in a name there and make sure it's active by seeing it's bolded. From there, we can create our work objects. In RobotStudio, this is a lot easier than doing it on the actual robot. We can just use the position XYZ. We'll want to change our defining type to 3-point. And then using the snaps feature, we can simply click on our first point in the X direction. After I selected that text field there, select our first position in the X, then select our second position in the X, and our third. Just like that, we can accept it. We can make sure our data type is correct, and we can give it a unique name. In this case, I'll call it palette A, and then we can create. You can't use a space there. That's my bad. So just click create, and then your workpiece will be defined. Now we'll want to add a second workpiece or work object. We'll call this palette B. And then we'll do the same thing. We'll frame it by points, 3 points. And then we'll select our X, our X2, and our Y. Accept and create again. Now that looks good. After this, we'll want to create some targets. We'll want to set our palette A as active again, and then we'll want to create a target. To do this, right click, and then click create target. You can use the snaps function once again, and simply select the top of your point. Now we can still see that our Z is pointing upwards. You'll want this pointing down, so the robot doesn't try and flip itself over. So let's modify this target again. And we'll rotate it again like this. And then just 180 degrees, so it's pointing down. Now that Z is pointing down, so it looks good. On the other side, we don't have our our workpiece inside the frame yet, but that's not a problem. Once we make palette be active again, we can say create a target again, and we can just select in the bottom of the holder. We'll just want to change our Z position. I know my part is 40 millimeters long and there's a 5 millimeter base. So we'll want to say 45 millimeters, and we'll add this point. Create the point. And once again, we can see our Z is pointing upwards. So I'll just want to rotate it. Modify target, rotate 180 degrees. Apply. And then you have your points defined. From here, you'll want to make sure that all of your data actually gets into Rapid. For this, we use the synchronize function. You can say synchronize to Rapid, and then you'll want, first, let me add, you'll want to add your targets to a path, so they'll actually copy in. You can just click add to new path, and then your two targets be added to paths. From here, we can simply say synchronize, and we can make sure that all of the appropriate objects are selected. Click OK, and then we'll want to open the Rapid tab. We can open our code here, and all this stuff natively imports into calibration data in module 1. From here, we'll want to put it in our actual code. Now, I already have some code written, but we'll just change the names of some of our Rob targets and our work frames so they all match. So we'll want to call our first target JMA and my second JMB just to match my existing data. Then we'll want to make sure all of our offsets are correct. Then we'll want to go over to the calibration data and copy over your tool and work frames. Then we can just change our names here to match our existing names. And then just make sure you don't ever reference something twice. So you're going to want to delete these, delete this. And then you'll want to also delete your existing safe position because we're going to define that with the robot. Once you have all of that set, then you'll want to start working on your code. You always want to make sure that you're working with a gripper that's not open or that's not closed when you initially go down to grab the part. So you'll want to make sure that you reset it to the open position. Sometimes grippers can take a while to actuate. So use the wait time function to ensure that the robot doesn't move before the gripper is fully actuated. You want to move linearly to your safe position. So we'll use the move L command, then our safe position. We use a V of 50, which is our speed. And then we use a zone, as it's not important to come to this point finally, which means it will stop at that point. From there, just make sure your work object is defined correctly. And then you'll want to use a for loop. We have a 3x3 matrix, so we're going to use from 0 to 2. We have both of the X and Y directions, so within your X for loop, you'll also want to call a Y for loop. It also has from 0 to 2. This is where I define my function and import my variables. You could see that I send two pairs of points as well as two work objects. These get imported into the pick and place function down here. This is all the data that's passed in right here. Within our pick and place function, we'll want to write a code so the robot moves. We're going to move linearly to our start position, but we're going to stop 50 millimeters above where the point itself is that you want to attach to. This is so when we come down on the point, it comes down straight. Otherwise, the robot might try to come in at an angle where it could conflict with the part. We'll want to set our gripper after we've moved down to the actual point, and then we'll want to wait 0.5 seconds again for that to actuate. We'll want to pull up vertically upwards as the sides of the point are defined, and if we pull the OA sideways, we'd crash the robot. Move linearly to the other side and stopping 50 millimeters above again. But you'll note that you'll have to change your work object when you come to this side. Refer to this as work object B. Then we'll again just lower ourselves by 50 millimeters, reset our gripper so it releases, and wait for it to actuate. Since we're going and doing the same thing over and over again, we'll just set our gripper again, and then we'll wait the appropriate time and move to our next position. Before we can actually run our simulation though, we'll need to define our inputs and outputs. This is so our end effector itself can actually work. To do this, we'll go into configuration, IO system, configuration editor. Then we'll want to set a signal. And then we'll say new signal. And we'll call this RO_0. This is going to be a digital output since we're sending a command between 0 and 1 or either 0 and 1. Our access level should be all, and our default value can be 0. We'll also add just a holding tag, which we'll call save tag. This again will be a digital output. So at this point, once we've added our tags, we'll want to restart the controller for this to take effect. This will take a second, but once it's restarted, we'll want to go back to the simulation tabs, and then we'll use Event Manager. This is where we'll add what our input and output signals do. The activation should be on, and the trigger type should be IO signals changed. You'll want to go and select your tag, and then select the condition that you want it to work under. Our action type in this case is going to be attaching the object. We'll want to attach part 8, which is our workpiece, to my mechanism. You'll want to make sure it's in the correct position, but we'll check this when we actually run it for the first time. Once we're good with this, we just select finish, and then we'll want to add our detach, which will just be at the opposite trigger condition. In this case, that trigger condition is signal false. Our action type is detach object, and our object is part 8, which is detaching from my mechanism. We'll also want to move our gripper into the correct pose. So we'll go again, select our tag, select the condition, and then we'll just say move mechanism to pose. My mechanism, and then in this case, when this is active, we'll want it as closed. You do need to add a tag here to make sure nothing bad happens and it will let you save this. So we'll just call this a save tag. I've already defined that in my inputs and outputs. This tag doesn't do anything in our case, but it will let us use this command. Once again, we'll just want to add one more to represent and our gripper goes to the open position, which is signal false. Move mechanism to pose again, my mechanism, and then our pose will be the home pose. We'll want to click finish here. And then we should be all set. We'll want to use our flex pendant to add a safe position. We'll want to once again make sure we're in manual mode. And then we'll just want to jog down to a position that's well and clear of the robot. Or we'll want to, before we do this, we'll want to mount our mechanism to our flange. We'll use layout, my mechanism, and then we'll just say attach to our faceplate, which is link 6. We won't update this since we've already correctly positioned this previously. Then we can jog our robot to define a safe position. This looks like it's well and clear of both work pieces and is an adequate safe position. To add this, we'll want to say this is going to be program data. It's going to be another Rob target. And then we'll just call it safe position or safe POS, since that's how I have it in my code. We'll now run our simulation and make sure everything works. We'll see there that our orientation on the part is not quite correct. So we'll just want to stop our simulation. Then we'll go back to our event manager function. And then when we attach our object, we'll just want to make sure that we properly define this. We can go back to view and we'll see that we'll just want to rotate it around the x-axis by 90 degrees. This is easy to do. We'll just say 90 degrees here, and then we'll click apply. Now we'll just want to put our part back in its original position. We'll want to click apply. We'll want to rotate it 90 degrees as I shifted a little bit there. So we'll just go back to 0 here. 90. Now it looks good. And now we can just run our simulation again. Just like that, you can click play on the simulation tab and you can watch your robot do your code. It shouldn't have any problems, but if it does, I'd just always check your rapid positions and check your work objects. Those are two common errors. If your robot flips upside down, just make sure to have those points flipped to the Z direction pointing downwards. But aside from that, usually you don't run into any issues. In the case you do, I'll leave my LinkedIn description or my LinkedIn profile link, as well as my email address in the screen of this video, so you can send me a message, and I'd be happy to help you out. Otherwise, thank you for watching the video, and if you have any questions, just let me know.